This picture shows the replication of the very recognizable double helix DNA. Obviously, something this general won't help explain the entire process, so we're going to go in depth and show you each step of DNA replication.
Here's a complete strand of DNA fully put together. However, once it enters this helicase enzyme, the hydrogen bonds holding the strands together are split apart, making two separate strands. However, these strands want to come together again, so it is necessary to have a single-stranded binding protein, or SSBP, on each strand to keep them apart. One, action.
Now that we know how DNA is split apart, let's see how each strand replicates.
First, let's start with the leading strand. This is the strand that ends in the 3' end, so its complementary strand must end in a 5'. New nucleotides are always added through dehydration synthesis on the 3' end, so this replication process is simple. The DNA polymerase just constantly adds nucleotides, or dNTP, to the 3' end of the new strand, making a continuous replication process.
Now that the leading strand is explained, let's move to the more complicated lagging strand.
Since each strand in DNA is anti-parallel to the other, the lagging strand must end in 5'. This makes replication more complicated, as new nucleotides cannot just be added continuously, because DNA must always be added onto the 3' end. So, the single strand must be replicated in sections. In one section, RNA primase adds RNA primers, or NTP, using dehydration synthesis. The single strand These primers provide a base for the DNA polymerase to create a new strand. The DNA polymerase then adds new nucleotides to the 3' end of the new strand, jumping from one primer to the other. Then, the DNA polymerase removes the RNA primers and fills them in with more DNA. These fragments are then fused together by ligase, making the strand seamless. The complete strand then moves on, and the RNA primase begins the process on a new single strand.
So now 2 complete DNA strands have been created. You can see why the lagging strand is called like that, because the process is much slower for that. Thank you for watching. We hope you learned something.